our big overarching question is, can we improve the delivery of nucleic acid-based therapies using peptide-based delivery systems? We really want targeted systems and making sure that we're getting into cancer cells. So using these types of systems, peptide-based systems, can really help us to get there.
The fundamental question we're going to answer is that how this the competition between the spin, charge, order, and the lattice degree of freedom are happening at the atomic level, and how they are going to form this topologically protected spin texture. So which is going to have a very profound impact to the spintronic technology and the quantum information science.
I've been working on recommender systems. So when people use these systems, they often actually don't know what they like. And so I'm trying to build a recommender system that helps you figure out what you want, rather than, giving you items based on what you want. Thinking about what are your long-term goals and what are the things that you should aim for at the current moment to reach those long-term goals.
First, I want to maybe use my research to bring the awareness of the security threats or vulnerability from the hardware side. On the other hand, just try to improve the security to ensure the privacy for the next generation AI systems.
Our major idea is, can we use the brain to better diagnose the brain itself? So it's mostly about looking into what's actually going on inside of patients' brains and using that to develop better tools to give doctors to actually diagnose the disease.
The point of this project is to look at the microstructure, so the few levels down than what we can see of a metal, and see how we can improve that microstructure without making a new material, which is costly and takes a lot of time, to be more fatigue resistant. So our bridges, our structures, our cars, everything lasts longer.
The high-level question we're trying to answer is, can we make sensors and diagnostic tools that are typically restricted to a laboratory environment and very expensive, can we make them very cheap such that we can do diagnostics in a portable setting or at home, and potentially using color changes so that you can measure samples with the naked eye.
What I'm trying to do is to understand how the logistics planning decisions can be made to be adaptive to the evolution of a hurricane situation. Currently, the logistics planning is done in a static place where you have to run into the dilemma of when you should make that decision. So being adaptive is making a more robust plan, which is going to benefit the people who may be affected by the hurricane.
This project is for a new manufacturing method to try to mimic some fascinating surface functionalities we see in nature. I will be very excited to solve this issue, to see what's really going on when you shoot a laser on glass and these super small structures are formed automatically.